Okay, first for the introduction is the background study. The background study is focused on the topic of linear equation. The elimination method like Gauss elimination are most likely to have large runoff error when using a large set of equation. However, iterative method like Gauss-Seidel give us more control of the runoff error. So this study we use the Gauss-Seidel. Next is the objective. The objective is to identify the appropriate metric method to be used, and the second one is to determine the internal force X1, X2 and X3. Okay, the next one is the problem statement. The problem statement is we have a truss which consists three members AB, BC and AC. Then for the joint we use three equation, which is 4x1 plus x2 minus 6 equal to 0. For joint B, x1 plus 3x3 minus 8 equal to 0. For joint C is 3x2 plus 2x3 minus 10 equal to 0. So we need to find the internal force x1, x2 and x3 of statically determinate truss using the Gauss-Seidel method. We need to use the calculation and round at the 4 decimal place. Okay. Next is the flat table. For the fact is every truss involving internal force that can influence the truss member. The idea is using 3x3 metric method to calculate the internal forces of the truss. And then the learning issue is how to find the internal forces x1, x2 and x3 using Gauss-Seidel method. And the action is use Gauss-Seidel method to obtain the value of x1, x2 and x3.
Hi, my name is Muhammad Izzuddin bin Zahinuddin. My matrix number is DF220148. Today I will present about the literature review. Okay, this study provides a true review of the Gauss-Seidel method on iterative approach for solving system of a linear equation. This method is popular due to its simplicity and easy to use. The review covers the theoretical foundation of the Gauss-Seidel method and explore various computational strategies used to enhance its efficiency and convergence properties. The Gauss-Seidel method is an iterative approach for solving a linear system of equation Ax equal to b, where X is a matrix, X is the vector of unknown, and B is the vector of constants. This method iteratively refines the solution vector X using the following formula that state in the slide here. Next, I will enlighten about the computational technique which we use the parallel implementation. The sequent nature of Gauss-Seidel method makes it difficult to parallelize. However, some parallelism can be achieved by using the multicolor ordering approaches and domain decomposition. First is domain breakdown. The method of domain decomposition entails splitting the matrix A into more manageable submatrices that may be handled separately. Boundary conditions are adjusted as each subdomain is solved repeatedly. Next is ordering in multiple colors. With multicolor ordering, distinct colors are assigned of various matrix rows so that no two neighboring rows have the same color. This enables parallel execution by permitting the simultaneous update of all rows that have same colors. So the application of the Gauss-Seidel method is widely used in various fields, including the engineering for solving large systems of linear equations in structural analysis, fluid dynamics, and thermal analysis. Next is the computer graphic in iterative solver for rendering the equation, and lastly for economics for solving equilibrium models in computational economics. The Gauss-Seidel method is fundamental iterative technique used to solve linear equation system. Although its fundamental implementation is simple, its performance can be greatly improved by using different computational techniques like SOR, preconditioning, and parallelizing strategies. Gaining knowledge of this technique, their use can help solve large-scale linear systems effectively. That's all from me. Thank you.
Hi, my name is Muhammad Nabi Mahiri. For this project, I will discuss about the methodology to calculate the Gauss-Seidel method. Step to calculate the Gauss-Seidel method. First is to understand the information given. For this study, the information that given is the equilibrium equation for the transistor. Second, change the equation to the metric format. Third, checking the metric is diagonal matrix or not using this formula. If the metric is not a diagonally matrix, rearrange the matrix position until we get the diagonally matrix. Step 5. Write the Gauss-Seidel formula. After that, from the Gauss-Seidel formula, making the Gauss-Seidel table calculation. This table calculation provide easy calculation using the calculator. After that, step 7, stop the calculation if achieve the stop condition. The stop condition is the x to the power of k plus 1 minus of x to the power of k less than the epsilon value, that is 0.0005. Lastly, list the answer for the x1, x2 and x3.
For calculation part, we need to transform the equation into metric form. After that, we need to find the main diagonal. Main diagonal had a certain requirement that need to be fulfilled, which is the value at the main diagonal must be bigger than others. From metric 1, we can see that the condition not been fulfilled, so we need to rearrange the metric so the main diagonal value will become the biggest from the others. As we can see from the metric 2, the main diagonal value is the bigger than others. After the main diagonal achieved, we can write the Gauss-Seidel formula, which contain of x1, x2 and x3. After we write the formula, we can switch x1 into A, x2 into B and x3 into C to simplify our calculation. After we done writing the Gauss-Seidel formula, we can calculate the value of A, B, C using this table. So for K1, the value of A can be calculated with 6 minus 0 divided by 4 and we get 1.5. For B, 10 minus 2C is 0 divided by 3, we get 3.3333. And the last one is C, 8 minus A, which is 1.5 divided by 3. So we continue the calculation until the minus value lower than epsilon. Since we got the minus value less than epsilon, we can write the conclusion, which is since max x8 minus x7 equal to max 0.001, 0.003, 0.001. The max is 0.003 less than epsilon, which is 0.005. So the solution is x8 equal to 1.0527, 1.7x95, 2.3157 transpose. Then we need to change it into the metric form, which is x1, x2, x3 equal to 1.0527, 1.7x95, 2.3157.
Hello and good day. My name is Muhammad Nurafan bin Azman, using the number metric of DF220083, and I will be presenting about discussion. In the calculation, with using the table of the value of k, after k8 minus k7 carries a maximum value of 0.0003, which is below the epsilon value, 0.0005. The final answer will be the 8th value of k with internal force member of AB equals to 1.0527 equal to 10. And then internal force of member AC equals to 1.78 0.95 kN, and finally internal force of member PC equals to 2.3157 kN.
Okay, as a conclusion, the main objective of our work is to determine the internal forces S1, S2 and S3 using the appropriate method. We are capable of finding the exact answer using the Gauss-Seidel method. The answer we got is 1.0527 kN for member AB, 1.7895 kN for member AC, and 2.3157 kN for member CB. This proves that we achieved our objective of finding the appropriate method to find the internal forces.